Okay, I think this video that we're on now is very, very important. So what we've seen thus far is we've been introduced to a position time curve. And we've often seen these curves with a straight line and a constant slope. But remember, what does the slope of my position time curve indicate or refer to? Well, we know that my average velocity is my delta x over delta t, or my instantaneous velocity is dx dt. So remember, the velocity is the slope of my position time curve. Okay, very good. Then, what is my acceleration? Average acceleration is delta v over delta t, or instantaneous acceleration is dv dt. So what we see here is that if we take the derivative of my position time and if we take the second derivative of my position time, we will get whatever our acceleration is. So we take the derivative of position time, we get velocity. We take the derivative of velocity with respect to time, we get acceleration. Okay, so if you have a straight line with a constant slope, a constant gradient, then we know that you would have, if that's a positive slope, right, then you're going to have a positive constant velocity. What happens now if you've got a curvature? In this example, you've got a positive, or what is it called, an upward curvature. This is an upward curvature. That is a downward curvature. So what does that mean in relation to my velocity and my acceleration? Let's just get some more space here. Okay, bear with me. Okay, what does that mean? So now, if we want to draw, let's get some more space here. If we want to draw now the velocity time curve for this, what is it going to be? Well, the simplest way, remember, we're looking for the slope. The slope of the position time curve is my velocity. So what is the slope at this point? Well, it's kind of near zero. Let's assume that this is doing that. So it's zero, so the slope there would be zero, so my velocity is zero. What happens if I take a point and I draw the tangent line there? It's positive, and it's more obviously higher than zero. So at this point, my velocity is positive. And I just take points along this curve and I draw the tangent lines, meaning the slopes. And I see that these slopes are increasing. That means for this kind of curve, it seems my velocity is increasing. You'll see that that would happen. And so I've got this kind of velocity. Now, what does this mean now with regard to my acceleration? I know that my acceleration is the slope of my velocity. So what is the slope here? It is positive and it's constant. So I'm going to have a constant acceleration. What about this one? Why don't you pause the video and try to draw the velocity time curve for this one? Okay, pause it and come back. Got nothing to lose. Okay, so my velocity time, what's happening right there? What's the slope? The slope is very positive. So we start at a high value of velocity, relatively. And then we just draw tangent lines. As time goes on, we draw our tangent lines. And we see that the slope is still positive, but less positive. It's still positive, but less positive than that one. Still positive, so we're going to see it go down like this. And then, if this has this kind of turning point at the top, we know that the slope there is zero, so my velocity is zero, So this is going to basically be my velocity time curve. And what's going to happen if I draw my acceleration time curve? Well, what is the slope? Number one, it's constant. It's constant as we go along, and it is negative. So I'm going to have a negative acceleration, right? So this is what it says here. If my xt curve has if the xt graph is a curve, it has a curvature, then if it's an upward curvature, this is an upward curvature, smiley face. Okay, that looks like a very evil person. A smiley face, upward. Then it has a positive acceleration. If it has a downward curvature, not so smiley face, then it is negative. It has a negative curvature. Okay. All right, so try that also for these ones. Does this have a positive or a negative curvature? It has a negative curvature, so this means that there'd be a negative acceleration. This has a positive curvature. Okay, so let's just try this. Why don't you try this example on your own? That didn't help me much. Let's try and get this out of here. Okay, sorry. Anyways, draw this guy. Try draw this guy in terms of its velocity and acceleration, and try and draw this guy in terms of its velocity and acceleration. Okay, see you in the next video.